Students, in the previous video, we have discussed about the introduction of RNA interference and the process like dicing and slicing. And in that, we have discussed that the dicing process that is mediated by a protein that is known as dicer. So here we are going to discuss the structure of a human dicer protein. It may have several domains. They are helicase, pass domain, two RNA3 domains, two double-stranded RNA binding domains. They are DUF2A3 and double-stranded DSRBD RNA binding domains. And the pass domain that may be comprised of three subdomains. They are PV, argonate, and Swile. So altogether, there are six main domains. They are helicase, pass domain, two RNA3 domains, and two double-stranded RNA binding domains. So you can see various domains. They are arranged in a particular way or in order from N-terminal to C-terminal region of this dicer protein. See, this is the structure of our dicer protein, and see, this is the pass domain, and see, this is the double-stranded RNA precursor molecule. See, all the double-stranded RNA precursor molecule having a 3' overhanging region. Most commonly, this 3' overhanging region having around 2 nucleotide overhangs. So this pass molecule that interacts with the 2 nucleotide overhangs at the 3' end of the double-stranded RNA precursor, and then the coming adjacent to the pass, there are two RNA3 domains. We have already discussed about that. So this RNA3 domain that may positioned at over here. These two domains forms a pseudodimer around this double-stranded RNA precursor, and finally that makes a cut over here in the double-stranded RNA, and then there evolves a double-stranded RNA molecule from this. And that double-stranded RNA molecule is known as siRNA. It's having normally a length of around 22-23 nucleotide. We have already discussed that this is the precursor double-stranded RNA molecule, and the dicer that makes a cut over here in the double-stranded RNA precursor, and then there forms the siRNA molecules. These siRNA molecule, we have discussed that it's having commonly length of around 21-23 nucleotide. So see here in this the same thing we are discussing here. So the pass interacts at the 3' overhangs of the double-stranded RNA precursor, and this RNase3 makes a cut over here in the double-stranded RNA precursor, and then there forms siRNA. The length of this siRNA that may actually connects with the length of this region. See, this is the pass domain, and this is the RNase3 domain. So there is a small region in between these two. See, this region is known as connector region. You can see that particular region here in this picture also. See, this is the pass domain, and this is the RNase3 domain. So these two regions may be connected together by means of a connector region. See, this is the connector region. If the connector region is longer one, then definitely siRNA that may get evolved from this process is a longer one, because if the connector is a longer, RNase3 that may get positioned away from this pass domain. So then the incision that normally can create in the double-stranded RNA may be away from the 3' overhang of the double-stranded RNA. So normally the siRNA that may get evolved from that process is a longer one. If the connector is a shorter one, then definitely RNase3 may get positioned adjacent to this pass molecule, and then the siRNA that may get evolved from that process or that dicer is a shorter one.